41. Let f be the antiderivative of little f of x equal to sine cubed x over the square root of x. If f of 2 equals 0, then f of 6 equals what? And when we first look at this, this is really like, I look at this, I have an antiderivative, and I see, so I know that f is the antiderivative of this ugly, I mean, it doesn't look terrible, but if I wanted to try to antiderive this, would I use substitution? And that's not going to work. Would I use integration by parts? That's probably not going to work either. So you might think, there's no way I can find this big F. But numerically, I can easily answer this question. It's based on the fundamental theorem of calculus, and that is this. I have this little f function. And this, I think it's the second fundamental theorem, I need to look at that, but would state that if big F is the antiderivative of little f, then the definite integral, so let me write this over here, the definite integral from a to b of little f of x dx, I'd take the antiderivative, put in b, put in a, that should be familiar, so that would be big F of b minus big F of a. Okay, that's from the fundamental theorem of calculus. And now, let's look back at this problem. I know big F of 2. I'm looking for big F of 6. So let me use these as the limits. Let's see what the fundamental theorem tells me. So if I have the integral from 2 to 6 of little f of x dx, that will equal big F of 6 minus big F of 2. Okay, let me add this 2 to both sides, and so I'll get from here is the following. Big F of 6, what we're actually looking for will be, I'll add this over here, big F of 2 plus my definite integral from 2 to 6 of f of x dx. And let's put some stuff in, so I know that. So let me bring in some more information. Let me use this. First, let's go to, I have this big F of 2, so I know this will be 0. Okay, that's part of the given. Plus my integral from 2 to 6. And I have the f function, so I'm going to have sine cubed x divided by the square root of x dx. And we're back to that point where if I wanted to do this by hand, I would have to find the antiderivative. But I'm not required to do it by hand, so let's go ahead and use the calculator, what's it good for. So I'm going to type this in and get an approximation. And just so that we're clear, this function, when I type it in to the calculator, I'll type it in as sine, it'll open up parentheses, x. I can actually put the cubed right here, but and it will work correctly, but let me just, for clarity's sake, so everyone's clear, put the cubed out here so we see it's the sine, that's to the third power, divided by the square root, let me write this how the calculator is going to show it, the square root of x, and it will have, and I'll put that inside parentheses. So that's how I'm going to write this function out. So let's go to the calculator and get it started. Alright, so math, I said before, it's down on the list, number 9. You can scroll down and see it. I'm going to put in my function. Actually, first let me put in the 0 plus. Doesn't make a difference, but what the heck. So 0 plus math fn int sine, hold on, sine of x, close that parentheses off, don't press tangent, close that one. Alright, so I have the sine of x to the third power, and we'll do the order of operations correctly, divided by the square root of x, close off that parentheses. Okay, so I have the sine, parentheses, x, close off, cubed. Alright, so dx from 2 to 6. And now the calculator actually does an approximation method. It approximates it using a Riemann sum with a ton of steps. But I press enter, negative 0.433, and I look back in my answer choices, and A is negative 0.433, so my answer is A.